is going to be the limit of this function as x approaches 4? Well, the first thing we can try is direct substitution. We can just say, well, what happens when x is equal to 4? Well, when we plug x is equal to 4, we'll notice that in the denominator, we'll get 4 minus 4, which means we're going to end up dividing by 0. So that means we can't do that. We're going to have to do something else. Well, we can maybe try factoring or reducing this function in some sort of way to change the denominator to hopefully get rid of that problem of dividing by 0. Well, what can we do? Well, it's not very easy to really factor or reduce the numerator here, but an identity that will be very helpful is the following. The identity that a cubed minus b cubed is going to be the same as writing this expression out. Now, why do I say a cubed minus b cubed? Well, first thing that you should note is that when you see a cube like this, well, then you ask yourself, okay, we have x cubed, that's our a cubed, but how can 64 be the same as b cubed? Well, that means that 64 has to equal to an integer to the power of 3. Well, is there an integer that you can multiply by itself 3 times to get 64? And the answer is yes. 64 is the same as 4 to the power of 3, right? Because 4 times 4 is going to equal 16, and then 16 times 4 is going to equal to 64. So, therefore, this could be the same as 4 times 4 times 4 is equal to 64. So in this case, our b is going to be 4, and we're going to get something like x cubed minus 4 cubed. And that's going to be the form that we're going to want to use for this. So where do I want to do? Well, what we can do is we can just rewrite this top expression in this format, knowing this conversion. So there we go, we've rewritten the numerator using this identity that we know. And what do we notice? Well, we notice that the numerator is the product of 2 brackets. And what do we notice? Well, one of these brackets can cancel with the denominator, right? If you just imagine there to be some brackets, that you'll notice it's the same thing. Well, this same thing divided by itself is just going to equal to 1, right? So we can cancel this and say it's just equal to 1 times whatever. So it's 1 times x squared plus 4x plus 16. So we can just ignore the 1 and just say our new function is going to be x squared plus 4x plus 16. What do we find now? Well, now we can directly substitute x equals 4 because I don't see any way we're going to break math. So what do we find when we plug every position that has an x with a 4? We get an expression like this, and what is this expression going to be equal to? Well, 4 times 4, or 4 squared, is going to equal to 16. Similarly, plus 4 times 4, which is also going to equal to 16, plus 16. So it's going to be 16 times 3. Well, 16 plus 16 is going to be 32. So 32 plus 16, well, we know 32 plus 10 is going to be 42, plus 6, that's going to be 48. So the limit as this function approaches 4 is going to equal to 48.